This is an attempt to show you here how to scale your data and how to descale it. This is very useful for when you're running neural networks. For neural networks, particularly, what you'll need to do is, it's good to scale your data before that, not feed raw data to your neural network, but scale it because the neural networks prefer uh, scaled data. Like this means when you have different dimensions of data. For example, here today we're going to be talking about a wind turbine dataset. For wind turbine dataset, you have features which have very large scale and other ones which are very low scale. Here you can see that. Um, you can see that the mean values for the power generated is about 1000 kilowatts. For wind speed is about 7 meters per second. This is very big difference in scale. Similarly with some other features here. And yeah, so neural networks don't particularly like um, raw data and negative data as well, like negative values. So it is recommended that you scale your data once you feed it into the neural network. And um, if you want to demonstrate your results, particularly for time series analysis, what's very useful is after you have run your neural networks, you apply inverse scaling. So inverse scaling is very much like scaling, but you revert it back to the original data scales so that you can understand exactly what the data means. Okay, here we go. So here, first of all, we start with importing the libraries. So we've just imported pandas and scalar from scikit-learn. This is what we're gonna focus on for this example. As I mentioned earlier, here our analysis is going to, our example is going to use a turbine, wind turbine for Texas. We import this as a CSV file. And we read this to have a look at exactly what we have as data here. We have a whole year. This is 8,760 hours of data. So we have a number of features. You can see we have timestamp, system power generated, wind speed, wind direction, pressure, air temperature. And you can get a rough feel of their scale when you do raw.describe. This is a pandas function, which gives you a brief stats summary. So here you can observe the max values of each of these features. So you can see that the maximum generated power was about 3000 kilowatts. Wind speed was about almost 20 meters per second. These are degrees of the wind direction, 360 degrees. Atmospheric pressure and air temperature. We continue forward. What we have is we're gonna get rid of the timestamp feature because that is currently an object. We cannot convert that one to, we cannot scale it in the way it is right now. So we're gonna get rid of it by selecting only the features we want to use for example, training of neural networks, as we mentioned here. And then what's very important is that when you do the scaling, you understand what type of shape of the data is. I'll explain a bit later why this is very important, but it's worth checking, like the number of observations, the number of features, how this is, what is the shape. If you have, if you use a dot shape function for pandas, it's going to be very easy to see. Then if we continue forward, now we scale the data here. This is in my scalar. and we transform it after that. And here you can see in the next cell, you can see number of features have lost actually the labels, and we still have the number of observations as originally, but their maximum value has turned into 1 and minimum values are 0. So we've just scaled it from 0 to 1. If we continue forward, we have now here we're going to apply the inverse scaling, and when you inverse scale, you apply essentially the scalar dot inverse transform function. It is embedded into the ScikitLearn, and voila, you get the result at the end. So you're back to the original dataset. So why this is so you can see that the end product is again made out of 8,760 rows and 5 columns. What's very important here is that when you inverse scale it, you inverse scale the same shape of data as it is being scaled initially. And another thing is to pay attention to when you inverse scale it, where you have positioned the data, the data, the way it is when it is scaled, and the way you feed it to the inverse scale transform function. Where do you feed it? Because depending upon where in which column you place it, it's gonna descale it in a different way. You can see here, this is column 0. So column 0 has been essentially converted back to 1766 kilowatts. Here you can observe the same value, but if that scaled, if we were to change the position, mix them up here in this place, once we scale it, we would not be able to recover the data in this meaningful fashion to the way it was. Okay, I'm gonna leave it here for you to test it yourself, and I'm gonna attach the code in the description below. Thank you.